Okay guys, the next series that we're looking at would be our phase notes, except instead of actually taking notes today, we're just going to do some example problems, just kind of refresh you on everything that's going on and what we're expecting, especially on this next little bit that you're going to do after you're done with these notes. So each one of these you're going to do in your phase 1 note boxes. So this would be phase 1, phase 2, phase 3, phase 4. So you're going to have 4 solid example problems of how to solve a substitution, all plugged in to your phase notes to help you on the next part of the assignment that you're going to be dealing with. So when I'm dealing with this first one, I'm just going to start up here. Negative 3x plus 2y equals negative 2, and y equals 1/2 x minus 3. Okay? So if I follow my pattern, I'm going to find my slope-intercept equation, and I'm going to plug it into that y, which gives me negative 3x plus 2 parentheses 1/2 x minus 3 parentheses equals negative 2. Okay? Now I'm going to follow my pattern. I'm going to distribute, I'm going to combine like terms, I'm going to isolate my x, and then I'm going to divide, which is solving. So I'm going to distribute first. Now I have negative 3x, 2 times 1/2 is 1, 2 times negative 3 is negative 6, and all that equals negative 2. Now I'm going to combine my like terms, and I get negative 3x plus x is negative 2x minus 6 equals negative 2. Okay? Then I'm going to isolate by moving the negative 6 by adding its opposite. Now I'm left with negative 2x equals 4. And last but not least, I'm going to divide both sides by negative 2. That goes away, and I'm left with x equals negative 2. Now the final step I need to do to solve that is just plug that back into my equation. So I have y equals 1/2 parentheses negative 2 minus 3, which is y equals 1/2 of negative 2 is negative 1 minus 3, so y is equal to negative 4. So my solution to that would be at my x value, okay, would be my x value is negative 2, and my y value is negative 4. Or I could just rewrite it like this. But you have to be able to see them both ways, because that's what it's talking about. Okay? Now for our phase 2 practice problems, it looks a little bit different. We have 2 equations in slope-intercept form, but that doesn't mean that you can't substitute. Okay? So all we're going to do is pick whatever one we want and then solve. So let's take a look. Let's just do this guy, and we're going to plug him into that y. So I have 2 over 3x minus 1 equals negative x plus 4. Okay? And now I'm just going to solve for x. Okay, this is a lot like what we're doing solving algebraically. We're just going to work it out and solve for x. So we're going to take, we're going to move all our numbers to one side and all our x's to the other. So I do that by adding the opposite. So I'm left with 2/3 x here equals negative x plus 5. Okay, I'm going to move this x over here by adding its opposite. Okay, so now I have 1 2/3 x. In fact, I'm going to take it out of 1 2/3. I'm going to put it into mixed fraction form. So to do that, I'm going to go 1 times 3 plus 2. So I'm going to call this 5/3 x is equal to 5. Okay, I'm going to get rid of this denominator by timesing by 3. So now I have 5x equals 15. I'm going to divide both sides by 5. And I'm getting x is equal to 3. Okay, so now that I know that x equals 3, I just need to take that and plug it back into one of my equations. Let's take the negative x plus 4 equation. And I'm going to plug that 3 in for my x. Y is equal to negative 3 plus 4, which y would be equal to 1. Y would be equal to 1, so I can leave my answer set as like that, or it helps if I also write the coordinate set, because it's expressed that way a lot of times. Okay? So, for my phase 3 practice problems, it's a little bit different again. Instead of having slope-intercept form, I just know what x equals, but it doesn't have to be in slope-intercept for me to substitute it, so I'm just going to take this value here and I'm going to plug it in there. So if I had 3 minus 3, x equals 3 minus 3y, and x plus 3y equals negative 6, I'm just going to take this and plug it in here. So I've got 3y, or 3 minus 3y plus 3y equals negative 6. Okay, now I'm going to combine my like terms. So I have negative 3 and positive 3, which is 0, so that goes away. And I have 3 equals negative 6. Now, if I have 3 equals negative 6, what does that tell me? It tells me there is no solution because that is not possible, okay? And if I wanted to, I could have checked this by going like this, m equals, in this case it'd be negative 1 over 3x minus 2. And then up here, if I did the same thing, I would have had x plus 3y equals 3 if I made it into standard form. And I would have got that this guy's equation is m equals negative 1/3 x for my slope, and then 1 for my y-intercept. And if that's the case, I'd have the same slopes but different y-intercepts, and I should have expected to get no solution. Okay. Now in our last phase example problem, this is what we're dealing with. Again, it looks a little bit different. There's really nothing in slope-intercept form, so I have two choices. I can either convert one of these into slope-intercept form, or I can just solve for one of the variables. Okay, in this case, out of all the variables I could solve for, I think this is the easiest x to isolate. So I'm just going to isolate it by taking the opposite of 2y to the other side of the equation, and I'm left with x equals negative 2y minus 4. Now I can take that and I can plug it in to that x. So I'm going to have 4y is equal to 3 parentheses negative 2y minus 4 parentheses plus 12. And now it's no different than what I've been doing. I'm going to distribute. I'm going to combine my like terms. I'm going to isolate my x's, and then I'm going to solve. So I'm going to distribute in. Now I have 4y is equal to negative 6y minus 12 plus 12. Okay, my like terms are right here. Negative 12 plus 12 is 0, so I'm going to leave it as 4y equals negative 6y. Okay, now I'm going to isolate this guy here by moving him to the other side of the equation. Now I have 10y is equal to 0, and then I just need to solve by dividing both sides by 10. 0 divided by 10 is 0, so y is going to have to equal 0. Now that I know that y equals 0, I can just plug it back into this equation. Negative 2 times 0 is 0, minus 4 is negative 4. So x would have to equal negative 4. And if I wrote it as a coordinate set, it'd be negative 4, comma 0. And that would be my answer. I know those look a little different, but if you reason through them, that's why there's only a few of these on your quiz that you're taking, or the little worksheet that you're going to be completing on the back of your notes for the day. But that's kind of a good example set. And of course, if you're confused on it, since this is a self-paced lesson, feel free to pop back to the video and watch it again and fast forward to the pieces you need in order to help you solve these. Okay? Do your best.